Okay, so guys, what's the first thing we learned about? It starts with an O, and when you're doing science, it's important to make what? Observations. Good. So everybody has to know this. Why? Because we got a test coming up in a few days, and you want to make sure that you understand this stuff. And you make observations with what? You got 5 of them. 5 senses. And there's 2 main types of observations. Who knows that? No? They both start with Q. Right, qualitative and quantitative. And what's the difference? Exactly. One of is numbers. So things like length or time, or what else? I don't know. Mass. Good. Things that you need scientific tools for, right? Scientific equipment, scientific tools. Here's a pencil. You want? Here. Okay, great. And then qualitative would be things that they don't have numbers, right? Quantitative is numbers. There's numbers that you can assign, and qualitative is things like color or smell or taste. Yes, things that you have to describe, right? Things that you have to describe, but you cannot add a number to it. Very good. There's multiple smells and you can describe them, but I can't just give you a number. Here's smell 23, and then you immediately go, oh, yeah, okay, I get it. When I went to I got to go to Mission Barbecue Saturday. Has anybody ever been to Mission Barbecue? I better pause the video at this moment because I don't know if I can make advertisements or anything like that, and I don't want it to be construed as an advertisement, but I want to briefly tell you about Mission Barbecue. Okay, so now we're recording again, and let's continue. So now we use these observations to do science, and when we're curious about things, we usually ask starts with a Q. We usually ask a question, and this is really where science begins. Some of these questions happen out of pure curiosity, and we would call that what type of science? Yeah, pure research. And then some of these questions are to solve a problem or to have a goal, and that's called what? Right. Okay, so there's 2 types of questions. Ones that are just derived from pure curiosity, and then there's ones that are derived to solve a problem. Curiosity? I don't think I'm spelling this right. And then one's this is solve a problem or goal. So now you know these are things that are going to be on your tests. I think you're going to do well or to have a goal. Okay. So now when you have a question, we formally call this a research question. A research question. And it's just a fancy way of saying, well, we have a scientific question that we want to answer. But there's 2 things, and I'm actually going to do a brand new slide on this one. Can we move on now? You don't have to write every single thing here. Just write the main things. So there's 2 things when making a research question that are vitally important. Does anybody remember from Mr. Sam Filippo's class last year? There's 2 variables. Thank you. There's the one that I change. It's called the independent variable. Independent variable. Very good. And how do you remember that? That I change it? Well, there's a giant I at the beginning of this word. I change that. So for instance, I can blow a balloon up to different sizes. I can blow a balloon up to 20 centimeters. I can blow a balloon up to 50 centimeters. I can blow up a balloon to 100 centimeters. So I'm going to say the size of a balloon. We're going to do our own little mock experiment here. Size of balloon. So I can blow it up to different sizes. And then there's something called the dependent variable. Good job. And that one's the one that I measure. It's something that depends on this. Dependent variable is the measured variable. It depends on the independent. That would be like the number of pieces after you pop the balloon. Number of pieces. You feel like it has nothing to do with what? Of course it does. Because look at, we have two variables. Haven't you ever wondered how many pieces are going to end up if the size of the balloon is like 2 meters long or 1 meter long or 50 centimeters or 40 centimeters? Haven't you ever just stopped to ponder that? Well, let me ask you a question. Do you think you have the answer to that? Do you think you know that? What's your answer? So every time you blow up a balloon to how big, it's going to make 9 pieces. You never know. Thank you. So she's exactly right. You can't know until you do what? An experiment. See, now that's the next thing. But let me ask, let's go before the experiment. What do you think's going to happen? Oh, somebody said hypothesis, right. But what do you actually think's going to happen? The bigger the balloon, the what? The louder it is? The more pieces, the less pieces? How many pieces do you wish? Bubble gum in a dish. Remember that game? Did you guys ever play that? All right, so hypothesis. Look, somebody said it. So let me see a show of hands. If the balloon is bigger, it's going to have more pieces. If you believe that, raise your hand. All right, if the balloon smaller, it's going to have more pieces. Who thinks that? Not even one person? Not even one person? We usually have 2 or 3 people. So we'll go with what the class consensus is. What? Look at this. If, that's a very important word in this hypothesis thing. See, we're trying to guess what's going to happen. If and then. Excellent. If the balloon is bigger, there you get it. Then you will have more pieces. Good. So this is our hypothesis. You will have more pieces. Okay, so that's what we think. We don't know that for sure, though. We can't guarantee that. But what we can do is what somebody said earlier. We can do an experiment. And you know what? If we do an experiment and we find out that the bigger that the balloon is, the more pieces it makes, I think we can have a pretty good confidence that our conclusion is hey, the bigger you blow up a balloon, the more pieces it's going to make. So a good experiment has 2 variables, an independent variable and a dependent variable. Okay? It only has one independent variable. So we can't use the size of the balloon and the color of the balloon and the brand of the balloon and well, you can, but it would be not a very good experiment. You see, we want to keep everything else that starts with a C. What? A control or constant, controlled variable or constant, same kind of thing. But you're right. We want to control all other variables. So I'm going to put a little note here. That was a very good point you made. Control all other variables as much as we can. Control all other variables. And the reason why that's important, because if I take like brand X balloon and we go, hey, look at that, and then we take brand Z balloon and it does something totally different, how can we really know if this is the way it is? Or if different people blow up the balloon, maybe somebody has bigger lungs, right? I was a swimmer in high school. I used to be able to, I don't know if I can anymore, swim all the way at the end of the Olympic pool and all the way back underwater, one breath, 100 meters, one breath. I don't know if I could do that anymore. Some people have more powerful lungs, right? So maybe somebody else blowing in air blows it in a little harder and it makes the balloon have more pieces or something because there's more energy. I don't know. Does the color of the balloon matter? That's just such a great question. Because maybe there's like a dye or something they use that weakens the rubber of the balloon, right? And maybe like a green balloon is weaker than a red balloon, and we are thinner. So we don't know the manufacturing process. So we should use the same brand, the same color, the same person blowing them up, or even better, like some kind of machine to blow them up. So it does it just the same way before we pop the balloon. Okay, so that's how you make a good experiment. And the other name for an experiment is a test. Okay, test experiment. So I'm going to pause the video there because I think we pretty much hit all the main things we need to hit for this particular part. And we're going to do an activity now.